You know what I love about big machines? Most of them exist because somebody had a problem that sounded completely ridiculous. Need a tunnel through a mountain? Fine. Build a machine that eats rock. Need to move an entire offshore platform across an ocean? Put it on another ship. Need an excavator to work on a slope where even walking feels sketchy? Give it legs. Yeah, engineers are weird, in the best possible way. Here, we figure out how these machines actually work, who runs them, and why we need them in the first place. So if you're into giant machines, strange engineering, and the stories behind all of it, you're in the right place. Alright, let's see what they built this time. You know, sugar beet harvesting looks pretty simple from a distance. Drive through the field, pull the beets out, done. Then you get close to a ROPA Tiger 6 SXL and realize, nope, there's a lot going on here. This thing is almost 15 meters long, and the XL version can harvest 8 or even 9 rows at once. And that wider setup is actually pretty clever. Instead of rushing through fewer rows, the machine can move slower, cover more ground in one pass, use less fuel, and make fewer turns across the field. Up front, the leaves are removed first. Then lifting shares work underneath each row and gently pull the beets out of the soil. From there, they don't just fall into a box. They travel through a whole cleaning system of conveyors and huge rotating strainer wheels that shake away soil before the beets finally reach the bunker. And that bunker holds more than 43 cubic meters, around 30 tons of beets. Here's the fun part. The empty machine already weighs more than 33 tons, so when that bunker is full, it can be carrying almost its own weight again, just in sugar beets. That's a pretty serious grocery run. Power comes from a 16-liter Volvo Penta diesel. In the strongest version, it makes 796 horsepower and 3,650 newton meters of torque. But the really useful number is what happens down low. At only 1,000 engine revolutions per minute, it already produces almost all of that torque. That means the Tiger can keep working hard without screaming at maximum engine speed all day. And fields aren't flat. That's where this gets really neat. 6 hydraulic cylinders can tilt the chassis against a side slope by up to 10%. So while the ground underneath is leaning, the machine can keep itself much closer to level. That gives the tires better grip, helps reduce deep wheel tracks, and makes a machine this size a lot less sketchy on uneven ground. Inside the cab, the operator gets 2 12-inch displays, digital cameras, automatic depth control, and online diagnostics. If something goes wrong, a service technician can even connect remotely to help figure out what the machine is doing. One Danish contractor reported harvesting 930 hectares in a single season with a 9-row Tiger 6 SXL. And when the bunker is... Bridges have a weird problem. A lot of the stuff you really need to inspect is underneath them. And getting a person down there can be harder than finding the crack itself. That's where this thing comes in. The MOOG Bridge Inspection Unit. From the road, it basically looks like a truck carrying a folded pile of steel. Then it parks near the edge, and the whole structure starts unfolding. One section goes up, another reaches over the railing, and then a long work platform swings underneath the bridge. Honestly, watching it deploy is half the fun. It looks completely wrong, until suddenly it makes perfect sense. Inspectors need to get close. Not 50 feet away with binoculars. Close enough to check cracks, corrosion, bearings, joints, welds, and places where water has been slowly causing trouble for years. And on the larger MOOG MBI 200, the platform can reach about 20 meters horizontally underneath the bridge. It can lower almost 9 meters below the deck, rotate 180 degrees, and carry around 800 kilograms of people and equipment. With special equipment for inspecting bridge piers, the access system can reach roughly 80 meters downward. Yeah, 80. At that point, you're basically hanging a workplace down the side of a bridge. The story started back in 1981. The German city of Ingolstadt wanted a way to repair a bridge without completely stopping traffic. Alfons MOOG built the first MOOG Bridge Inspection machine for the job. A few years later, in 1984, MOOG sold its first truck-mounted unit to Switzerland, and according to the company, that machine is still working. By 2008, MOOG had built 400 inspection units. In 2015, number 500 left the factory, and MOOG reported that all 500 delivered up to that point were still in operation. That might be my favorite fact about this machine. Its job isn't dramatic. It doesn't move mountains or carry rockets. It simply gets people into the one place most drivers never see, under the bridge they trust every day. And sometimes, finding one small crack early is worth a whole lot more than the machine that found it. You know what usually happens when an excavator reaches deep mud or a swamp? It stops. Or worse, it sinks. The EIK Amphibious Excavator was built for exactly that problem. Instead of normal tracks, it rides on 2 huge sealed pontoons wrapped in crawler tracks. They spread the machine's weight over a much larger area, letting it move across mud, wetlands, shallow water, and ground where a normal excavator would need a temporary road just to get started. And yes, those pontoons can actually float. But floating is mostly a safety feature. For serious work in deeper water, EIK can add side pontoons and long steel legs called spuds. The spuds push into the bottom and stabilize the excavator while it works. With this setup, EIK says the machine can operate in water around 4 meters deep. The drive system is pretty clever too. Hydraulic motors are mounted at both ends of each pontoon, so one side pulls while the other pushes. Basically, it gets the same idea as four-wheel drive, except the wheels are enormous floating tracks moving through mud. Not exactly something you see on the morning commute. EIK started in Malaysia in 2000. Then, in 2006, the company developed its first amphibious excavator, the AM200. Since then, the idea has grown into a full family of machines. Today, EIK lists 11 amphibious models and exports its equipment to more than 50 countries. But here's something interesting. EIK does not publish the exact number of amphibious excavators it has produced worldwide, so there isn't a trustworthy global total available. The same goes for the factory cost. These machines are built in different configurations, with different excavators, booms, pontoons, and support systems. They are sold by quotation. For some perspective, an amphibious undercarriage alone can be advertised for well over $200,000 before you even put the excavator on top. But there's a reason people pay for it. On one waste pond project, an operator reported a productivity increase of around 23 to 24%, with roughly 500 tons of material removed every day. No draining the pond first. No endless temporary roads. These machines dredge waterways, restore wetlands, maintain flood control channels, clean ponds, and work in places where simply reaching the job can be harder than doing it. And that's what makes the EIK so interesting. It doesn't need good ground. It was built specifically for the places where good ground doesn't exist. Mud, water, swamp, fine. Just another day at work.